Bonds are debt instruments. So if a company or any entity wants to raise long-term debt, they can issue bonds, and so they take loans and in return issue bonds. Now bond valuation. What is bond valuation? There are some basic terms that you should understand for this concept, bond valuation. So these terms are, first is face value, which is denoted by letter F. So face value is the denomination or nominal value of the bond. Suppose if someone says bonds of rupees 1000 each, so that means face value is 1000. Remember, the bonds are not necessarily purchased at this price. The price at which bonds are purchased or issued depends upon some other things which you will learn about after having clarity about some more terms. Like second term is coupon rate, which is denoted by letter R. So the issuer of the bond or borrower promises certain rate of interest to the lender. So this rate of interest, so this amount of interest is to be paid to the bond holder, and this rate of interest is called coupon rate. For example, 5% government bond of rupees 1000 each. So 5% is the coupon rate here. So next term is coupon payment. Coupon payment. Actually, this is coupon payment for the borrower, but for the lender, it is income. It is a source of income. It is a cash flow for him. So coupon payment is calculated on the face value of the bond. Suppose in this example, if one bond of rupees 1000 face value has been issued to a person and it is carrying a rate of interest of 5%, in that case coupon payment will be 50 rupees. So the bond holder will get coupon payment at regular intervals, and at maturity date of the bond he will get redemption price. So redemption price at the maturity date of the bond. So this redemption price can be face value of the bond, at par, or at premium. So these are some cash flows for the bondholder: coupon payment and redemption price. So cash flows for the bondholders are coupon payment plus redemption price, which can be face value of the bond at par or at premium. And these coupon payments, he gets these at regular intervals. So these are cash flows for the bondholder. But remember, he has to get these in future. So what fair amount should he sacrifice now to get these future payments? So this fair amount is called present value of the bond or bond price. He has to sacrifice this value now, this amount now, to get these two future payments. This value is also called intrinsic value of the bond. So obviously this present value should be less than coupon payments and redemption price or face value at the maturity date. because he is sacrificing this amount at present. But how much less? This is decided by discounting rate, or we can also call it yield to maturity, which is denoted by letter D in percentage form and I in decimal form. So D upon 100 is equal to I, which is in decimal form, and D is in percentage form. So this discounting rate decides what should be the present value of the bond. So now we will learn about the concept of bond valuation according to present value approach. So present value, first coupon payment he will get at some interval. So present value of first coupon payment that bondholder is getting should include I. So it will be C. C is the coupon payment here, and 1 plus I. I told you I is the yield to maturity in decimal form. So 1 plus I. Similarly, PV of second coupon payment will be C upon 1 plus I raised to 2, and so on. And at the maturity date, he will get face value of the bond. I am assuming that he will get face value at par at the maturity date. So PV of present value of the maturity amount will be face value F upon 1 plus I raised to n. So total present value of the bond will be sum total of all these values, C upon 1 plus I plus C upon 1 plus I raised to 2, and so on, and C plus 1 C upon 1 plus I raised to n, plus F face value that he will get at the maturity date of the bond, 1 plus I raised to n. So as you can see, this is finite geometric series up to n terms. So sum of these terms, as you can remember, formula of sum of geometric series that is finite is a 1 minus r raised to n upon 1 minus r. So what is a here? A means first term. So first term here is c upon 1 plus I. And what is r here? R is the common ratio, that means ratio of two consecutive terms. Suppose we take second term divided by first term. So second term is 1 plus I raised to 2 upon C upon 1 plus I. So C will get cancelled with C, and what we get is 1 plus I. So R here is 1. Okay, let me do this again. C upon 1 plus I raised to 2 divided by C. So that means multiplied by 1 plus I raised to divided by C. So C will get cancelled with C, and this will get cancelled with this. So we get 1 plus I. This will be the common ratio. So A will be C upon 1 plus I, and R will be 1 upon 1 plus I. So substituting this value in this sum, so that we get the sum of these terms up to n, what do we get? PV is equal to A. So A is C upon 1 plus I, 1 minus R raised to n. So 1 minus R. So R is 1 upon 1 plus I raised to n upon 1 minus R. So 1 minus 1 upon 1 plus I plus this value. So I am writing this here. So f upon 1 plus I raised to n. So now PV will be C upon 1 plus I and 1 minus. If I take this to upper part of the fraction 1 plus I, then sign of n will change. As we know that denominator, if we take it to the numerator top part of the fraction, sign changes. So it will be minus n upon 1 minus 1 upon 1 plus I. So take LCM here. So 1 plus I. So 1 plus I minus 1. Solving this part. So 1 and minus 1 will get cancelled. 1 plus I and 1 plus I will get cancelled with each other. Plus, write this part as it is. Obviously, we can take this part to the upper part of the fraction here. So 1 plus I raised to minus n. So this is the formula for present value of the bond, or we can also call it bond price. So now let's solve two examples from your book M.l.aggarwal Applied Mathematics so that you get better clarity of this concept. So example number 1 is a bond that matures in 5 years, has coupon rate of 10% per annum and a face value of rupees 10,000. Find the fair value of the bond if yield to maturity is 8%. So given F face value is 10,000. So F is 10,000. Coupon rate is 10% per annum. So that means R is equal to 10% per annum. And that matures in 5 years. So N is equal to 5 years. And YTM, yield to maturity, is 8%. So that means D. This is denoted by D. So D is 8%. So D is 8%. That implies I is equal to D upon 100, 0.08. 8 upon 100, 0.08. So I will be 0.08. We will use this in our formula. So coupon payment. So what is coupon payment or C? Coupon payment or C will be face value into rate percent. So face value is 10,000 into rate is 10 upon 100. So it will be 1,000 rupees. So now using the formula, PV is equal to C 1 minus 1 plus I raised to n minus n upon I plus F 1 plus I raised to minus n. So PV present value will be, substituting these values here, 1000, 1 minus 1 plus I, 1 plus 0.08. So it will be 1.08 raised to minus n. So minus 5 upon 0.08 plus face value is 10,000. So 10,000, 1 plus 0.08. So 1.08 raised to minus 5. So now this is equation number 1. Let's solve this part. 1.08 raised to minus 5. Take this as x. Let's assume that it is equal to x. So now taking log on both sides. So log x is equal to minus 5 raised to minus 5 log 1.08. So now from log value chart we can read value of 1.08. So whenever we have to find a log value, we have to see whether it's more than 1 or less than 1. So 1.08 obviously more than 1. So first there are two parts in a log value. First part is characteristic and decimal, and then mantissa part. So first we have a look at the mantissa part from log value chart. 1.08. So without considering where the decimal is corresponding to 10, under column number 8, the value given is 0334. So this is the mantissa part and then decimal. So what will be the characteristic? For this we have to see whether the value is more than 1 or less than 1. This is obviously more than 1. If this is more than 1, we have to count the number of digits to the left part of the decimal. Number of digits here is only 1. Only one digit is there. So we have to subtract 1 from this. 1 minus 1 is equal to 0. So characteristic part will be 0. So log x is equal to minus 5 into 0.0334. So log x will be equal to minus 0.1670. Now we have to find out the antilog value of this value. But we know that mantissa part cannot be negative. It has to be positive. So to make it positive, 0.61670, we have to take integer value more than this. Just greater than this, integer value will be plus 1. Okay, so log x, we have to add plus 1 and minus 1. It doesn't matter if we add 0 to any value because it will be the same. So plus 1 minus 1 is equal to 0. So plus 1 will be added. Now take this part separately. Minus and plus. Minus. So subtracting 0.1670 from 1, we get 0.8330. So minus 1 part will be added later. So minus 1 means 1 bar. 1 bar is equal to minus 1. So 1 bar 0.8330. So log x will be 1 bar 0.8330. Now we have to find out the antilog value of this value. For antilog, we should consider only the mantissa part first. So 0.8330. So corresponding to 83 in the antilog value chart, under column number 3, what value has been given? This value is 6808. So 6808. Now characteristic part is bar 1. 1 bar, which is equal to minus 1. 1 and the same thing. So we add 1 to this. Minus 1 and plus 1 is equal to 0. So that means we have to put decimal after 0 digit in this value. That means at the starting of the value. So it will be 0.6808. So 0.6808. So x will be 0.6808. So log x is this value. We know that if log of x is this value, then x will be anti-log of this value. I should have mentioned it first. So anti-log of 1 bar 0.8330 is 0.6808. Now we put this value in our equation number 1. So equation number 1 is PV is equal to 1000 minus 1 minus 1.08 raised to minus 5. So instead of, in place of 1.08 raised to minus 5, we put here 0.6808 upon 0.08 plus 10,000 into 0.6808. This value will be substituted here. So we get present value as 3990. After making calculations, we get 3990 plus 6808. That means 10,798. So present value of the bond will be, or we can say bond price, or we can say fair value of the bond will be 10,798. So there was another thing, yield to maturity. So using present value formula to calculate yield to maturity is nearly impossible. So there is another formula for calculating yield to maturity, which gives us approximate yield to maturity, and that formula is C plus F minus PV upon N divided by F plus PV upon 2. So using this formula, we will solve another example, example number 5. A bond of face value 1000 has a coupon rate of 10% per annum, paid semi-annually. Paid semi-annually means half yearly, and matures in 4 years. So n is equal to 4 years. So if the present value of the bond is 1140, then find yield to maturity. So using this formula, we will calculate yield to maturity. So for this we need face value and we need coupon money. So for coupon money, we just need R. Coupon rate is denoted by R. So coupon rate or R is 10% per annum, paid semi-annually or half yearly. So we will divide it by 2, 5% per half year. So coupon payment will be face value into R%. So it will be a coupon payment. Face value is 1000 into 5 upon 100. So it will be 50 rupees. 50 rupees. N is 4 years. Multiplying it by 2, we get 8 half years. Rate will be divided by 2 and N will be multiplied by 2 to get half years. So now formula is approximate YTM is equal to C plus F minus PY upon N upon F plus PV upon 2. So C is 50 plus F is 1000. Present value is 1140 upon 8 upon 1000 plus 1140 divided by 2. So 50 minus 140 upon 8. So it will be 2140 upon 2. So it will be 1070. So we get 50 minus 17.5 upon 1070. So it will be 0.0304. So this value is per half year. If we want to calculate it as per annum, then we will have to multiply it by 2. So it will be 0.0608 in decimal form, and if we want to calculate in percentage form, then it will be 6.08% per annum. So this will be the answer.